plan on retaking the ACT. If you don't, then this is just good math for you. So,
I found it.
I'm so proud of you.
I can't find it. It took you long enough.
Darby nice.
I know it's a struggle for you, but I'm in agreement with whoever said that.
Stop.
All right, so number 35. The figure below is a section of a college basketball court. Square has sides that are 12 feet long, and I think it's supposed to say one side of the square is a diameter of the circle. The shaded region is to be refinished at that cost. Grab a seat in the back and here. Actually, hold on, Caitlin. Did you return the calculator that you borrowed?
Yeah.
Okay, so it's not mine. All right. So geometry was one of the main topics that people were like, yeah, I have a little bit of a struggle on geometry. So that's why I picked these two questions. So first things first, what can we use to find, what is it, the shaded region?
You need the area for the circle.
Okay, so I need the area of the circle. What else do I need?
And the area of the square.
Area of the circle. Okay, so what is the area of the circle?
Pi r squared.
Pi r squared, okay. Good. What's the area of the circle, or sorry, of the square? Length times width, but I would even do base times height, which the base and the height would be the same, right?
Yeah.
Okay, so that's a good starting place. Now, does anyone ever have trouble, I don't know if it's true for like y'all, but I know like when I do ACT prep a lot of times students struggle to remember circumference versus area. Yes? Okay. So one thing this is one of the things, like there's a calculus concept that makes it make a lot of sense, but one of the first things I ever noticed, golly, that's twice in a row.
It's star.
No, the first time wasn't. The second time I admitted.
One of the things that I've noticed before I learned this calculus concept to make sense of that area idea, remember area is always a unit squared, okay, centimeter squared. Whereas a length is, say, just centimeters. So centimeter squared, feet squared, etc. Area and circumference have exactly the same numbers and letters involved, okay? And so when I look at this, which of these two is going to give me a unit squared and which one's going to give me just the unit?
The area.
Well,
pi r squared.
there we go. So I would say just looking at that, r squared, that's the only place I'm going to get a unit squared. So that's your area. This then would have to be your circumference, the distance around it, right? Now we don't care about circumference, I just want to show that contrast of area versus circumference.
Perimeter as well?
Huh?
Isn't it also called perimeter?
Perimeter?
Or perimeter?
Perimeter. Perimeter is typically reserved for convex polygons. It doesn't even have to be convex, but polygons, not circles. But essentially, yes. It's just the distance around. Okay. And then, so the area of the circle, what would it be?
It's 56.54.
Okay, so I'm just going to leave it as the pi times 6 squared for now, but 36 pi. Notice the length of that square is 12, right? So the radius would just be 6. Notice writing out your formulas helps you see that. All right, area of the square then would just be what?
Sorry, I lied.
12 squared?
It's 113.
I was just looking at that, I was like, it's got to be more than 100.
I was
Okay.
about the half of it.
So notice 12 squared, 144, and that is true. Do we even need that whole circle? No.
We divided by 2.
We can divide it by 2. Now, so two things I will point out. These are both what, feet squared? We do need to keep our units in mind. I'm going to show you why in a second. Okay, so all I need though is this shaded region. How am I supposed to find that?
Subtract the total area of the square minus the half of the square.
So this is a common geometry thing that a lot of students miss, but if I want to find that shaded region, I just take one of the whole regions and I take away what I don't want, right? I want the square minus half of that circle. So how just go ahead and multiply it out to get rid of the pi. What do we get? 144 minus half of 36 times
That's
5.
87.46.
So like this whole thing
Yeah.
is 87.46
46. 46.
square feet. So I'm gonna pause there for a second, because obviously that's not the answer, it's not one of those answer choices. What do you do from here to find the answer?
It's $6.25.
So, I'm gonna slow down, and I do wanna point this out, I'm not saying whether you're right or wrong, I just wanna point this out to help in the future. How do you know it's multiplying and not dividing?
It's per.
I think the word per can mean division too, can't it?
Because per square foot.
Okay, so per square foot, say again, for each square foot. So what I will point out, if I have 1 square foot, it's gonna be $6.25. If I have another square foot, it's $6.25. If I have another square foot, it's another $6.25. So I'm repeatedly what? Adding. So repeated addition is shown through multiplication. Here's a better way to see it though, that I learned in my chemistry class as a sophomore.
Ew, stop. No.
Dimensional analysis.
Correct.
Yummy.
Guys, if you have units, this got me from my chemistry class as sophomore year all the way through engineering. If you've got units, make sure your units cancel out. It's $6.25 per square foot. Notice square foot divided by square foot, they cancel. And so I just multiply. If you have units on the ACT, you will or can use a dimensional analysis table like this to make sure the units cancel out. That's what I do every time. When I do ACT prep, I teach them to do that every time. It works. Okay? Well, that too, but it's not always going to be that obvious or that clear. That will help get you there. So what's the final answer though? 550? Okay.
Yes, I got 550.
Okay, next piece, number 52.
Wait, can I explain this one?
Sure, go for it.
Like for real?
Yes.
Stop wasting time, go.
Okay, so each shaded section is 36 by 2, correct? And we have
It's
4.
what? 36 by 2?
Yes.
So like this,
Yes.
36 inches long, 2 inches wide?
Yep. And
Okay.
we have four of all of the, or 4 of the 36 by 2s.
Okay, so what are you doing since you have 4 of
We
this?
multiplied by 4 first of all.
Okay, so 4 times 36 times 2?
And
Okay.
then the overlapping regions are all 2 by 2s because of the width of each. So since we have 4 of those, we subtract the overlapping sections. I think we subtract, 4.
I will point out, does this idea of having to subtract this out remind you of anything you actually studied in the stats class?
Like the probability of the intersection.
The probability of a union, and you had to take out the intersection with those Venn diagrams, because what did we do to each of these regions? We counted them twice, so I gotta take them out each once. So that's the most probably efficient way to write it out. And obviously you can use a calculator. This is just a fun nerdy part for me. Notice how they both have 4 times 2. So I'm actually gonna rewrite as 4 times 2 times 36 minus 2. So 8 times 34. So 240 plus 32. Yep, 272. Yeah, I guess that works too.
Because I did it the first one.
Yep. Okay, so area, keeping that in mind, that's how we calculate it, but we need to get going. Make sure your name's on it, I'm going to collect it, you're probably going to get a fine grade, but hopefully, and by probably I mean you'll get a fine grade because it's not a priority for my AP stats class. Hopefully you learned out of this situation though.
Yes.
Made some notes, learned some math, all
Do you
that
like my
fun stuff.
explanation?
Say again.
Do you like my explanation?
It was beautiful. Fantastic, just like you as a human being.
Thank you.
Can you pass your ACT questions up?
Is that a lion? Yes, Dumo. Yes, Ryan.
Okay, so quick, so I have graded the test. I'm not going to give the test back till after Thanksgiving break.
No.
First off, no. Second off, there's 2 people that haven't taken the test yet. Third off, no. Emerson and Raina?
We're not gonna
Turn off the
tell them.
camera.
Raina will be fine.
Raina will be fine. I'm
Just
not.
turn off the camera.
No. Okay? Well, I will turn off camera because there are 2 things I want to talk about before we continue. 2 quick reminders, guys. Hey, if you...
What was it?
I'm not going to tell you that.
Was it me?
We had a few ways, but there was one that was close.
What was
No,
the
I'm not putting
At least tell me if it was
What was the
One that was
meaning?
close to it?
I don't remember.
Was it me or not?
I don't know.
What was the median? What was
I don't know.
What was the range?
Median.
I don't know the mean, I don't know the median, so what makes you think I know the range?
So you don't know your 5-number summary.
Correct. Great, so the mean would not fit into the 5-number summary, but yeah.
Please tell us.
So, project reminder, Monday after Thanksgiving break, we are presenting on the projects. Traditionally, these projects are something that help grade significantly. Please make sure you're ready to present and talk. If you have not emailed me your draft of what you're presenting yet, do that so that I can look over it quickly and just give any small feedback. If you want to make edits. No, I have not given anybody feedback. That's what I'm going to do this weekend. That's what I'm saying. If you have not sent it to me yet, I need you to do that. Okay. So we're going to get back into this unit though. So please remember, inference procedures with quantitative data, with means. Guys, when it comes to these inference procedures, we're going to review all those ideas that we've been doing with proportions time and time again. That means it doesn't have to be a time to be frustrated. It means it's a time to realize the things that we didn't understand last time, to master confidence intervals and hypothesis tests this time. I just realized I have not put the answers up for the homework yet. I'll fix that. Were you the one asking me about that? So if you can, I will fix that. All right. So remember, all of this still holds true, which I realize I'm going to do something slightly different when we move into hypothesis tests today. But like, all of this from the foundation of this proficiency scale is still there. The only new thing is the standard error for x bar. So when we were looking at the standard error of p hat, what was the standard error of p hat?
The square root
Square root of p hat times 1 minus p hat divided by n.
Okay. So that was our formula, right? And the real formula, remember, was originally the square root of what?
P times 1 minus p. Wait. Yeah.
or divided by n.
No, yeah, divided by is the more mathematically precise way to say it, but I understand what you're saying. No, I mean, I've said it a few times, but
Over is choose. So.
it's more that over is just a locational thing, it's not a mathematical thing, that's a fraction bar that means division. But we had to use p hat when we didn't have a p. That's what I need us to recognize. We had to use p hat because we didn't have a p. Alright? That was only in confidence intervals, that was a hypothesis test, because we had a hypothesized p.
Correct.
Okay? Now, the true standard deviation of the sample means is what?
N or standard deviation over square root of n.
Divided by the square root of n, yep. Okay.
Sorry, divided by.
Yep.
Just corrected.
But in all reality, how often do we have sigma?
Usually never.
Never. Guys, if we're trying to do an inference procedure for the true mean, how do I have the true standard deviation when I don't even know what the true mean is? You don't, right? So standard error of this sample means is s divided by root n. Again, notice it's almost identical, it's just whether you have sigma or not. And we won't have sigma, okay? Now, this match pairs design, we're going to actually skip this. I have a much better activity than what mathematic does that we're going to do in the next half of this unit. So be aware, we're going to skip 11.4. We'll come back to it-ish later. Okay, so what we've been working on though is all about these standard errors, the critical values for sample means, the t-distribution. Remember, why did we have to develop a t-distribution?
Because to get a larger interval.
To get a larger width. What was, so creating a larger what to make a bigger, wider? Higher capture, or better capture rate, the correct capture rate. I can't make a higher standard error with the t-distribution. No, not a lower margin of error, a higher margin of error. Guys, remember, margin of error is equal to a critical value times my standard error, right? So the t is not affecting the standard error, but it is multiplying by the standard error, making a higher margin of error to account for more what again? Sampling variability. Guys, that margin of error is accounting for sampling variability, okay? And so we're making it wider, because remember we looked at that avenue where because S is changing, the interval was smaller or wider as a result, and so we had to make them a little bit wider there. Okay, and then is that 4C method of inference going away?
Never.
No, never.
Unfortunately.
Not unfortunately.
Very unfortunate.
I just realized that I have the word hypothesis on here. Take that out because we're talking about a confidence interval. Yeah. And we don't need an alpha. Man, I made a major mistake. Okay, so just choose your procedure and the parameter. You don't need the other parts of that for an interval. Okay. Oh yeah, thank you. I asked y'all to pass those forward and I didn't collect them. Thank you. Yep. Okay. Yep. Alrighty. So, how much screen time? I'm not gonna lie, guys. Yeah, the answer is too much. We need to be aware of this. I will say this: if you're looking at a high screen time, like you're one of those higher ones, you might want to consider what my wife does of have an app timer, because she loves to doomsday scroll as well. That's not ever been a temptation for me. I got really comfortable with watching TV and doing schoolwork all at the same time, which is easier to do than screen time. When the phone is like right there, it's your choice. I also just don't watch that much TV or whatever. But
We know you do.
yeah, sure. All that to say, legitimately, guys, screen time can be problematic for your productivity, for just honestly, in a lot of ways, happiness. Like it feels like a good escape, but guys, it's an escape rather than getting into work. Huh? It is also addictive. There's a lot of data behind that being addictive. Huh?
Be one with nature.
Well, or just, interact in person with people. Go play a board game. Go out to eat.
If you give me a flip phone, I'll use it for the rest of the semester.
You can go on a date with ChatGPT.
That's disgusting. Moving on. Okay, so what inference procedure did we set up here? A one sample t interval for a population mean. So that's one other thing is one of the things we always need to remember is inference procedures are all about the what? For the population. That was lovely. Remember, I don't ever need to make an inference about a statistic. Why? Or about a sample. Why? Why do I never need to make an inference about a sample?
Because
I have the sample. Guys, do not pick answers on multiple choice that talk about a sample. We're talking about a population, okay? The sample ones, throw them out really quickly. Parameter, the true mean screen time for all AP stats students, confidence level 95%. Appropriate conditions, what's the one we always have to have? Random, do we have a random sample?
Yep.
Yeah, they told us, I think, to treat us as a random sample. Okay, make sure, by the way, I saw this on the free response and I was nice on this one. Do not put random check. You need to say random sample at the minimum because there's random sampling and then there's random assignment. You need to make sure you say random sample check or random sample is stated. One of those two. Yes, Star.
I quoted what they said in the.
Beautiful.
Is that
That's ideal.
Okay. And then I said check.
That's perfectly fine. Okay. Literally steal what they say. 10% condition. Is it safe to assume that our 12 students is less than 10% of all AP Stat students? Keep that in mind. Again, you want to be careful with that language. You need to say, kind of give a number maybe, but safe to assume the sample size is less than 10% of all of whatever the population is. And then what was the last condition that was kind of problematic?
CLT.
Not central
large
limit theorem. Huh?
Establishing normality.
Okay, so establishing normality for the what?
The sampling is-
The only reason I say be careful just saying CLT is do you always have to say you satisfy the central limit theorem? Yeah, if the population is approximately normal, then we're good, right? So the sampling distribution will be approximately normal, right? But we did not satisfy the central limit theorem. And there's times where the population is not approximately normal, and the central limit theorem is not satisfied, but we're still okay because the sample is what?
Normal.
Not normal,
Marginal.
not heavily skewed, and no, and I will say this, I don't think I had this originally, no outliers. What was our problem?
It had
About
both.
longer. Yeah.
It was heavily skewed and it had an outlier. Not particularly, it's all about the skewness and outlier, but thank you for bringing it up, because that is a good consideration. Please stop talking. Anyways, yeah, it's all about skewness and outliers. If it's roughly symmetric without outliers, you're good. So even if it is bimodal, it'll be fine, okay? So conditions are not satisfied. General formula, I did not pull it out or put it into the slides, and I should have, But what is our general formula always? If you need the formula sheet, please look at it, it's on the front.
We estimate plus or minus the critical value on the standard error.
Plus or minus critical value times standard error, right? Guys, that's on the front side of your formula sheet. Please have your formula sheet out and looking at it throughout the entire set of lessons so that you can look at what these different things are, okay? I'll wait a second for you to get that formula sheet out so that you practice looking at it. There you go, I'm proud of you, Star. You're on it.
Did you ever do it all the time?
I don't know, do you not get enough attention at home? Like,
Oh, no, I never do. My
okay.
parents love me.
I think you can do it.
You think, so it's like it's too much and so like when he doesn't get that level, he's like, but look at me, that's what it is.
No.
I love you too, Star, I'm just kidding,
Thank you.
but also at the same time, dang dog.
He doesn't like
Is that lying?
So, specific formula, what is the point estimate that we're gonna be using?
X bar.
Yeah, remember, we're moving into true mean, right? We're looking at estimating a mean here, so it's gotta be an X bar.
T star.
Be careful
X bar,
that you're not
T
putting a p hat in there, so a t star, t critical value, times,
Divided by
so it'd be s divided by square root of n,
the number.
right? So s sub x bar, as Charlie's saying, but I'm gonna go ahead and put
So
s divided by root n. Let's plug in our numbers.
It was like 41.019 plus or minus.
You said, I heard you say 41, I know that's not right, what'd you say?
491.09.
491.019.
I have that written down there.
09.
So 491.091 times, okay, what was our critical value? I don't think it puts it up here.
Not minus, not plus or minus.
Sorry, thank you, yes.
Come on.
Plus or minus what?
Thank you.
2.228. And how do we get that critical value?
I used the chart. I did not know.
I would say, so, hold
By
up.
putting it into the calculator, the reverse feed, and then you put your
Oh!
freedom in.
80. Okay, so, yeah, the table is great. What is our degrees of freedom for that table?
1 minus n.
1 minus n?
Or
N minus 1, okay. So our degrees of freedom would have been, I thought we had 11 data points. Or we had 12 data.
We had 11.
Oh, we had 12 students, we only had 11. Yeah, I forgot that we only had a sample of 11. Who didn't send me their data?
Like 4 people?
Actually, there's a couple people, well, because Emerson did actually send me his, I'm still telling people about this 34 we're still baffled. You know, back on Veterans Day for him. Anyways, degrees of freedom then is 10. So you go to 10 degrees of freedom on that table, you go to what confidence level on the table? You have a 95% confidence level. Do I have,
I do.
does anyone have what?
In the car.
Anyway.
Oh, sorry, I do not have that, I can guarantee you that.
Kenny says ashy.
100%. It's my goal in life. So table here, right, so 10 degrees of freedom, 95% confidence level,
Wait, what'd you say?
there's my critical value, right? Now, Charlie, you did say, hey, I don't know how to find it using the calculator. So remember, on the calculator, we run everything through menu. Okay, where would I go from there? Statistics or probability works, because we need distributions, that's in both of those. What type of distribution do we need?
Breathe, take a deep breath.
So remember, we're working on t distribution. I have an area and I need a critical value, right? So I do inverse t. Now, what's the area if it's a 95% confidence level?
0.25.
0.025. Be careful with that.
That's not bad.
0.25. And what degrees of freedom? 10.
10.
2.228.
Oh, what the
Say again,
heck?
Charlie.
I had a
Right, that's because we did the lower end. If you did the 0.975, it would give you the upper end of the 2.228, but we're adding and subtracting, so it doesn't matter. Yeah. I will point out for anyone, for on the actual AP exam, right? Desmos, you will have this option here.
Don't we have a limited Desmos now?
I think so, but I think you still should have access to this stuff.
Yeah, I think
So if I go down to probability distributions, and I look at t distribution, so notice what does it ask for first up here? Degrees of freedom, which is 10. And then I'm going to just kind of go ahead and zoom in some. I will say you need to go a little past where you did in the past because it's going to be more spread out. Okay? No, come back. Is that tall enough? Okay. So there's my t distribution. Now notice I can go to cumulative probability. And are we computing area or are we computing some bounds?
Area.
Hold on. We already have what? We already have area, so we need to compute the bounds. Okay? I know, but it ain't just about you. So what area do we want? What's my confidence level? And well, I will say, yeah, we have to be careful. It is an inner, right? So area 0.95.
Oh, my bad.
And notice what's my critical value? 2.228, right? So the calculate Desmos, again, I like the Desmos component because it literally shows me that 0.95 area on the middle, and so that 2.228 is right there. So you can use the calculator, you can use Desmos, but what I told you, this is the one of the few times that I'm like, no, technology's lame, use that table. What's up? It died. And I let it stay dead because I don't care about it.
What, Mr. Kenny?
I know.
can't have my watch. I need to know what time it is.
Sorry.
Maybe
All right.
If you change it to the right
It's
I'll
10
fix it
after
afterwards.
Madeline.
Okay, what's S?
10 after Madeline.
That's 12:10.
Huh? I guess, what's S?
The 369.99.
Over square root
Oh,
of
yeah.
11.
Square root of 11. So notice it is in here, not degrees of freedom. And so, but remember, all you have to do is plug that in or write it out. Don't do all that work by hand because there's my interval, right? So we got an interval of 242.529, comma 739.653. Now, I don't think y'all got a chance to do the conclusion on your own. I'm going to give you just a few minutes to write out your own conclusion before we go over it, and we go over the next piece. While you write your own conclusion, if you want to talk to people, you can. I'm going to go ahead and start passing out the cookies for the next activity that we do after lunch.
Should we pass that out like for at lunch or beforehand?
Say again, Charlie?
Yeah, shouldn't pass this out after lunch so you don't like use them beforehand?
We have
Show self-control.
Wait, what? We're not gonna eat them right now.
No.
Oh, that's not my calendar.
Oh, you got Publix, right? You got. Oh, I thought you got like the bakery one.
Yeah, I almost did those.
The bakery ones are so good.
So good, they're fire.
I feel like these piece of meat.
But I actually thought that there might be some kind of bias if we did that. So I chose against that method.
Well, why?
Why? Like, cause it's good?
Because it's like it's not one of those package deals in comparison to Chips Ahoy, so. I just like it. The paper towels that I got.
I'm gonna blow up.
So you have tissue.
Well, I got paper towels specifically to put
Oh.
these
Are they
on.
in your closet?
Like, Madeline watched me do it. I know I did it.
Madeline, where are they?
Why'd you steal them?
I didn't follow them back in.
I know, it's true. There they are, found them.
There's 13. Oh, I could have told you that, but I thought they'd be white.
Why they gotta be white?
Because it's a paper towel. Paper towel is white.
With 67% confidence.
No one said that.
Thank you.
Yeah, I find it hard to believe we had 67% confidence.
Is it bleeding or something more far?
Star would be the one.
What's our problem?
I'm like, oh my gosh, this is how the world.
Obviously, do not eat these. So I will say this, we're gonna have to dissect these, so don't eat these, I can give you more afterwards.
Oh, with toothpicks?
I'm not.
We'll just break them apart.
I don't like.
Oh no, Star.
I'll eat them.
I had no clue you don't like chocolate or cookies, I know you're broken inside. This is why Star acts the way he does, because he's so broken. Alright, so what's our conclusion?
With 90-something% confidence.
Not with 90-something%, with
95.
95% confidence.
I don't have the paper.
The interval,
Ian, where is your backpack?
Dude, everybody can find the paper.
1.5 to 9 minutes.
ooh, I like the inclusion, or the inclusion of the minute, so 5:3 to 7:39.65 minutes. What? Thank you, Star.
Sorry.
Picture mean
True average
screen
of all
time
AP Stats student screen time.
Oh.
In minutes.
of AP Stat students.
You already said that.
So,
For your contribution.
can I infer this to everybody at Hillcrest High School?
No.
Can I infer this to AP Calculus students?
No.
Can I infer this to AP Lit students?
No.
No. I can only infer this to
AP Stat.
AP Stat students because that was our population that we randomly sampled from. I should have reminded you as well. Please remember, we did not actually satisfy that normal condition, right? So we would have to proceed with caution. I don't really think that this is a great example. Notice how wide this interval is. There's a lot of spread here, right? So that's something to keep in mind. Any questions about that conclusion? Nope.
Quiet, quiet.
Hey,
Mr. K, you like to say this?
Go.
You're so good.
Stop. Yes, they would.
Alright, everybody got their conclusion down?
Yes.
Was there a question below that?
Yes.
Do we have convincing evidence that AP Stat students are having more screen time than is recommended? Yes, why?
More than double, actually.
120 is not captured by the interval, 120 is not a plausible value. The minimum of plausible values is 242. I am proud that my screen time is actually under that interval, or under that recommendation.
No shot.
What's the recommendation?
Sorry. The 120 minutes that's on that sheet?
I don't have the sheet.
Oh.
That's
We just had
only 2 hours?
Huh?
What do you do with 2 hours?
Like under 2 hours?
He has a kid.
He doesn't watch.
I mean, I will say, I watch TV.
He watches anime on his smart TV.
Okay.
Oh, God.
Can you shut up? Gosh.
What's wrong with this guy? He's talking about me.
I didn't hear him. Alright, 4C method of inference. What do we have to include? Okay, so we gotta choose.
Check, calculate.
Choose what?
include.
So procedure and define.
I'm firm right now before seeing the
I'm tired of this crap.
I hope that no one ever forgets the 4C method of inference.
I'm tired of it, but. So I didn't write it down.
Choose, then what?
Check, calc,
What conditions do we need to check?
normality,
So, randomness,
random, normality.
10% condition, when
Normality.
what?
Normality. Approximate normality.
Sampling without replacement, okay? Now, what has to be normal though? We need the sampling distribution to be approximately normal, right? So what we can call this is the large or normal condition, is what they put in the textbook. I'm okay with you calling it that, but there's 3 options. Population is approximately normal. Satisfy CLT. Or sample approximately symmetric, not normal, symmetric without outliers. Oof. So choose, check, calculate. And guys, I cannot emphasize it enough. Practice using that formula sheet to do a general formula, a specific formula, and then plug in, but use that calculator. Hopefully, I know, probably tired of writing all this out, but hopefully, we're, do not forget the 4C method. If you are asked for an inference, what you want to use? The 4C method. We need to practice, we need to master, but we got to keep that in mind. You need that 4C method. When we get back from lunch, we are going to dissect these cookies.
With our pencils?
No, dude, just break it apart like a normal human being.
What are we, how are we gonna make, that's not like.
That's how you get lead poisoning.
Well, to be fair, it is graphite, not lead anymore. That's the good news. But,
Now you get graphite poisoning.
No.
star, why this way? Let me check one thing. Yep.
What?
You just said yes.
Yeah, we're gonna have to skip the check your understanding with this. We'll go to 10.3 and knock it out. Can you what? No. No? I'm gonna torture you all Thanksgiving break. You're gonna go to sleep tonight and you're gonna be thinking about it. You're gonna go to sleep tomorrow night, you're gonna be thinking about it. You're gonna be eating turkey on Thanksgiving and you're gonna be thinking about it.
What if he doesn't eat turkey?
Mr. Kenny, what if I bring you a Thanksgiving gift?
No.
Mr. Kenny, for Thanksgiving, what would you like? Watch me do it.
Okay. I'm gonna assume Tilly will be here in a second. Is that who we're the only person we're missing? Yep. Well, Phoebe, did you close the door so Talia can't even get in?
It was closed before.
Trash!
Oh.
Dang, I did way too hard. Alright. Yeah, by the way, guys, if you need to turn your Ferret models back in, or not, if you need to, I need them so I can make scans. Confidence intervals and hypothesis tests. The hypothesis test, I know I didn't get a chance to make scans of, for sure. Yeah. The girl was fighting in
Well,
the
she was
back.
not that, and she was getting rowdy, and I was, she was
Hypothesis
just
test,
getting rowdy,
yeah.
she was really heated, so I was like, so I went
Yeah.
to the bathroom.
Was she spicy? Was she spicy?
Did you ever do yours?
Especially you could up the window so
Nope, nope.
it wouldn't pass you.
Thank you, sir.
I know, but I went
All right.
and got someone on the side.
So, let's go ahead and get started. At some point today, I do need your Ferret models.
Again?
Yeah, because I didn't get a chance to make scans. So I just figured both of them to be safe. Hypothesis test and confidence intervals. Star, did you hear me?
Yeah.
Pete, did you ever turn this one in?
No.
And you still didn't finish it?
That's real.
Those are like low priority, like doing the homework.
Hey, Mr. Kenny, I'm not gonna lie.
Helpful in the moment.
I don't care about these Ferret.
I'm not gonna lie, y'all are wrong for this.
Hey,
I kid you not, like,
class, Mr. Kenny puts time and effort into making sure.
Ian.
well, it's not that, guys, listen, let me emphasize this, okay? The Ferret models, I think part of it is a lot of us are just writing down definitions. We need to write down the connections among things, how things work, not just pure definitions. We need to look for the warnings in the textbook because it's the small details that make a huge difference. And practicing without understanding what you're doing doesn't make any sense. You have to understand what you're doing so that when, or like the concepts behind it, so that you can be successful when you start practicing. Just back in the corner. All right,
Mr.
but-
I don't have the other one.
well, that's probably not. The confidence interval one. Sure. All right, so we're gonna move into the 4C method for a difference in population means, okay, or for a confidence interval. And so we're gonna do something a little fun. Instead of doing half the class gets a Chips Ahoy cookie, the other half gets off-brand, I need you to do this quickly, but I need you to dissect the cookie and record the number of chocolate chips on the board up here. And so I'm gonna put Chips Ahoy, I'm gonna put the other one, and I'll create a file that collects all this data. So you have your 2 cookies, break it apart, figure out how many chocolate chips there are in the Chips Ahoy cookie, figure out how many chocolate chips there are in the Publix cookie, and if you need a reminder or be shown which one is which, let me know, okay?
Regular. Public.
No, Chips Ahoy are the wrinkly ones.
Oh,
Yep, that one's Publix.
I don't know.
I know.
Wait, what are you?
Yeah, that's your Publix, that's your Chips Ahoy. So dissect it, tear it apart. I would probably do it not on your paper that you have to write on, sorry, maybe on the paper towel. Does anyone want an extra paper towel as they dissect these things? Okay. Yes. Do not do 2 variable. Because
So what do I?
because 2 variable would be like bivariate, would be bivariate data. So you would do 1 variable and you would do 2 for the number of lists. Whoops, no, you accidentally just, there you go, now, yep. And then you put your 2 lists down. Okay, alright. Now, again, can we do all this in the calculator? Yes, but let's try to do this by hand to make sense out of what we're supposed to write out. Okay?
I'm on, you on one.
Talk to somebody next to you. Come up with the inference procedure, the parameter, and the confidence level that we should write down. And then we will talk about it in just a second. So talk to someone next to you. Turn and talk.
So can you give me some data?
Mr. Green, salute. I don't know why I'm making you do this.
Because you, huh?
See?
What am I seeing?
Like, well, the numbers aren't right.
Because you did 2,
I did not. I did 1 variable.
you did 2. That's the only reason why I would give you the wrong numbers completely. You do 1 variable, you do 2 lists.
Oh, 2 lists. That's still
I
one list.
did do the 2 variable and I got the same first numbers.
Yeah, but it's not gonna give you the right standard deviations and stuff. There you go.
Wait, what's the difference?
I got to put it into my calculator. Do it, Kim.
You know what I want?
Sure.
And
Right in there.
Isn't it a
Okay.
3.0?
I said the difference, you did the difference.
So,
What do you mean?
what type of procedure should we be writing about here?
That's going to be the next 1 minus the next 2.
So be careful, because we gotta remember, is it an interval or is it a test?
I mean,
Do we have hypotheses? Do we have a significance level? So yeah, be careful with that. So procedure, so you could even for this just say a 2 proportion, nope,
Yeah, it would be 2.
2 sample T interval for what?
For B of x1 minus B of x2.
Ooh, I'm glad you actually said that, Charlie. Be careful. It's not gonna be x bar 1 minus x bar 2. Why is it not gonna be this? 'Cause that's the sample. Remember, we already know the sample. What do we want to know about? Mu. So for the difference mu sub c minus, just put it right in front of the projector, minus mu sub p, right? So it's the true difference in those populations. Guys, do not forget, inference procedures are all about the population. Alright, so what confidence level? 95%. Okay. Parameter. So mu sub c minus mu sub p, the true difference in what?
And chocolate chip count.
You're missing something. True difference in
And mean
mean
chocolate chip count.
chocolate chips. For what? Chips Ahoy and Publix.
Publix. Public supermarkets.
Chocolate chip cookies.
Put on the camera, right?
Uh,
Yeah, the camera's right in front of you. Oh, we got it.
stretching, Dixie, or?
Oh, yeah.
Okay. Do you need to scoot so you can write that down, or you
No, I
already got
got
it? Okay. Okay, it says assume conditions have been met. What would the conditions be?
Normality.
Random.
So random, is it safe to assume that those boxes of cookies are random cookies? That they're representative of the population?
Yes.
Probably, yeah. Is it safe to assume that the 12 and 12 is less than 10% of all chocolate chip cookies for each? Yeah, definitely more than 120 of each of those cookies out there. Is it safe to assume the population is approximately normal?
Yes. Wait, what's the population?
Yeah, we don't know. The population number of chocolate chips in a cookie?
It's not safe.
It's not safe. Do we satisfy the central limit theorem?
No.
No. So what do we need to do since we don't have a normal, we don't know the
Make a
population?
graph.
Put it in a graph.
We need to create a graph.
Data and statistics.
So go to data and statistics. So let's check out Chips Ahoy.
Wait, how did you do
Is that roughly symmetric without outliers?
Nope.
Not for real.
Let's check it as a box plot. That's usually safer. Roughly symmetric without outliers? Yeah, definitely. Hey guys, box plots will show it a little bit better. On the AP exam, if you have to do this, draw out that box plot to show that it is roughly symmetric without outliers.
What's it called? The line of this not the. How do you draw it?
So draw that out. Publix. Is that roughly symmetric without outliers?
Yes.
So do we satisfy that large/normal condition? Yeah. Okay. Notice both distributions, the samples are roughly symmetric without outliers, so it's safe to assume that. By the way, there is one other thing to remember. Independence is one sample independent of the other sample.
Yeah.
Like the Publix did not affect the Chips Ahoy. So it is independent random samples. That's important. Okay, not just random samples, but independent random samples. One does not affect the other. So it's two sample. Satisfied 10% condition, and we satisfied that normal condition. Notice we needed both of the samples to be roughly symmetric. Okay, I want you to take the next 4 to 5 minutes to write out your general formula, your specific formula, plug your numbers in. Do not run it in the calculator until after you write out your formulas. Okay?
I didn't know how to get the box.
You have to grab it first. No, it's not, you can't, no. You can't do two variable, dude. You can only do one variable.
But I still play.
Don't do that.
But I can do.
No. You good?
No, like I was thinking that shit calculated.
It's two samples, so you have to do two different graphs. Then you go to menu and you go to plot type. You get two variables, so it only lets you do a scatter plot.
Oh, no, I have one. I know it's a plot plan.
And then click here. There it is. But if you put two variables there, it's only going to be a scatter plot. Okay? Guys, by the way, don't forget you need a formula sheet to write out the general formula and the specific formula. Now, remember so were you looking at this formula sheet as you wrote this out? Because here's the thing I want to remind you. So are we looking up here or down here? Uh-huh. And do you have one population or two populations? So notice, use that formula sheet there to help you write that formula out. What is that? Oh, CV, got it. Now, remember, same thing, notice up here we said two sample t interval. So here or here. So notice that's your statistic, not an X bar. So take advantage of that formula sheet. How did you decide your t-star?
Well, I wasn't too sure about it, because, we have two different minutes. So like, I was wondering, like, do you add bigger every?
So it's a good theory. It's called pooling the data. You only really do that when your sample variances are almost the same. So hold off on that. Yep, same thing. How did you decide what t was? What's your degrees of freedom? So if you have moved into the plugging in, which hopefully we are all there, which by the way, that's your specific formula. General is stat plus or minus critical value times that. That's fine. But, so, huh? You can. So like, you can skip the general, but the general is this one here. That's your general formula. Specific is once you substitute in. Okay? Or you write with this. Yeah, and that's what I do on the AP exam. Okay? Alright, or when I work through these free response questions. So let's talk about our critical value really quickly, because a lot of this seems to be that we're using 2.201 as our critical value, but why in the world are we doing that?
Because.
Hold on a second, let me find. Alright, so y'all did 12 minus 1? Whoa. Okay. Okay, so you just did 12 minus 1, but here's the thing, we have two different samples, right? So why do you assume it's just 12 minus 1?
What if you,
So then 24 minus 1 is an option, right? So here's the thing, I want to emphasize this really quickly as you're working through this. With two sample, you have two options. One, you can either take the lower n and subtract 1, okay? The lower sample size. So lower sample size. And do n minus 1. Now, that's essentially what most of y'all did, right? Because they were the same sample size. And so that worked in this case. Notice though, I did not add those two sample sizes together. Okay, there is something called pooling our data. You can, you'll see it in the textbook, read about it, but don't ever do that. In a pooled data set, what you're going to do is you are going to add the two samples together, but you're not going to just add them together, you're going to add them together and then subtract. Any guesses? You're going to subtract 2. But, don't do it. Okay? Pooling the data is very inaccurate if the variances are not similar. Okay? And there's better ways. So, this is the conservative approach. Because what happens when my degrees of freedom is lower? What happens to our critical value? It gets bigger, right? So this is the conservative approach. Here, is the alternate approach. I'm going to tell you this, I don't memorize this formula. It's a hard pass. But here is the alternate, or the more precise approach that you can use. Okay, population mean or mean difference. Hold on 1 second, let me find it. No, I don't want significance test, there we go. Oh no, I want 7C. Alright. That's right, that's right. Ooh, here we go. That's what you get. I hope that was at least star. Was it star?
Yes.
Yes.
Yo, this is like D1.
Oh my god.
What?
We don't know.
Y'all are D1 hatred. Hey, that's my pencil. What?
Alright, y'all want to memorize that formula?
Yeah.
No.
I have zero desire. In fact, once upon a time when I first started teaching stats, I memorized that formula, but goodness gracious, that looks awful, doesn't it?
I'm gonna learn it.
Don't do it. Does anyone know why you don't need to actually learn that formula?
This is irrelevant.
No, we're actually going to use it.
It's probably just in
No, because we have a what? Oh yeah, we have a calculator. Hey guys, do this really quickly for me. Okay. So, in the calculator, add a new page, and add a calculator page, and let's run this interval. So we're going to come back to all that in a second. But hit menu for me. Go to statistics, confidence intervals. What type of confidence interval? So notice it's a t interval, and it's 2 sample. So you need number 4, 2 sample t interval. And let's go ahead and do data. It's already there, right? We'll do it as stats in a second. But if you have raw data, put in your raw
I
data.
don't have the data, man.
Oh, that's a bummer. Just follow along then. Chips Ahoy and Publix. And notice, this is why I brought this up earlier. Confidence level is what? 95%. Are we going to pool our data?
No.
No, don't pool your data. Just hit OK. You see that degrees of freedom right there?
Where? Oh.
That's definitely not 12 minus 1, is it? That degrees of freedom is that formula. So when you run this in the calculator spits out your degrees of freedom for you. Okay? So you got it? Wait, hold on. Yep. Yeah, that's it.
Here's the confidence interval. That means we have to make is.
Although your numbers are off.
Stop shaking.
What if we don't have raw data and you have to do all that?
How did you get 1.531?
My hair.
Just looking at both. What was the last data on it? But that's all it is.
I think I fell asleep in the shower.
Let me look at the box top later. But all that to say, do we need to know that degrees of freedom formula?
Ew!
No. But say again. What we have is good enough. What the calculator spits out is good enough. I will point out, and if you're going to actually get the real critical value, then the one tricky part is you have to go through distributions, inverse t. Why are you throwing stuff across the room? 0.025.
Is that not your pencil?
What was it? 18.8 something?
248.
248. So you would have to put that in. That's the actual critical value that you want to use. 2.09. Now, if you put the 2.20, guess what? It'll be fine. Was it 2.2? 2.201. That'll be fine. Just run the interval in the calculator. Let it spit out the degrees of freedom and report your
They
degrees.
could have just like put over focus.
Yeah, well, the formula with the values plugged in. Yeah. Because here's the thing, if you don't do it this way, where you run it like this, you would put in a critical value that's not 100% accurate. Ian, you awake with us? You live? Yeah, so running the test here gets you the degrees of freedom, allows you to get the critical value. Now at the same time, you could, and it would have been fine, just done the 2.201 for your T star and then run the calculator and gotten the interval this way. The calculator is not going to do it off of that degrees of freedom of 11 though. It's going to do it off of that degrees of freedom. Okay. So, oh my gosh, I quit. Okay. Say that one more time.
When you do it with the smallest one and then subtract one, that gives you lower freedom, so it makes it a little bit bigger.
It makes it wider, exactly. So when you do the n-1, it is conservative. It'll definitely have at least the capture rate that you want, but that 18.8 is a more precise capture rate, yeah. So x bar c minus x bar p plus or minus t star times the square root of, by the way, why is this formula our standard error for this? Where's this coming from?
The formula sheet?
Yeah, but why is this on the formula sheet?
Because there's two possibilities.
Yeah, there's two populations, but like why is it s squared divided by n?
Oh, wait, isn't is the variance, right?
I would say, so remember, can we subtract those two standard deviations? No, I have to look at the variance, and what do I need to do with the variance? I need to add them, so it's the variance of c, I'm going to say hat, plus the variance of the Publix, so variance of chocolate chip cookies divided by the sample size, plus variance of Publix divided by the sample size, and then I would have to take the square root of that. So remember, we're adding the variances there. It's not brand new information. Okay, all that to say, we do need to finally wrap this up in the last 5 minutes. Plugging in our values. So pulling those numbers from what it was. What was the interval though that the calculator spit out?
-1.9.
I don't remember.
-1.9.
-1.
Oh my gosh, can you just let -1.912 to
5.41.
no, fine. So interpret your interval. So really, I'm just gonna leave it here. Alright,
God bless.
bless you, with 95% confidence, this interval, ... Okay? The bigger question I have is, do we have convincing evidence that there is a difference in the average number of chocolate chips in Chips Ahoy and an off-brand?
No, we don't. You know why? Because 0 is plausible value.
We do not. So we don't have convincing evidence. Because why?
0 isn't an interval.
Plausible value.
Oh, I really like the way that Charlie was saying
I
that.
said that like 5 times.
Oh, I'm so sorry, Star. So mu sub, do notice I'm using mu, not x bar. Why? Because it's all about the population. So the difference being 0 is plausible. So don't forget again, it's all about a population, not a statistic, a population. And it's that the difference in the population of 0 is plausible. Yes, Madeline?
I didn't write Chips Ahoy out.
Yeah,
Do you have to define that somewhere?
well, I did in the
So
parameter in the choose.
if you write Chips Ahoy minus Publix,
Yeah.
like in words, and then you
Yeah. If you define these symbols, one, it would be obvious, at least to me as an AP reader, that you meant Chips Ahoy minus Publix. But two, if you define your parameters well in the choose, then you can just use this a little bit later. Now, in the conclusion, I will say, I would say the true difference in the means of Chips Ahoy versus Publix, okay? Alright, so confidence intervals for a difference in means, which I meant to set this up a little bit. For the sake of time, let's just quickly pull up what mathematics said and talk through some key details so that you have the time to write it down. Where is their stuff? So there's, yeah. So 4C method. Okay, so please notice this 4C method, again, 2 sample t interval for mu1 minus mu2. All about a population, make sure you emphasize that. Okay, notice this has to be independent random samples, right? We have 2 samples that gotta be independent. And we gotta satisfy 10% or normal / large sample times how many? 2, okay? There's our specific formula, and I don't love the way they wrote that, but that is it. Just because I don't like the slash, it needs to be vertically stacked. And then conclude, we are 95% confident. And then remember, whatever you define as your parameter, so also include confidence level and parameter, however you define your parameter in the choose is how you should write about it here. There were some of you who only got a P because of the way you wrote the parameter in the choose, but because you used that same parameter in the conclude, I was able to give you full credit on the conclude. So however you define the parameter in choose, use that in the conclude. Finally, evaluating the claim. Remember, if they're both positive, that's convincing evidence that the first value is greater. The first population has a higher value. If they're both negative, that's because the second value is greater, right? And there's no convincing evidence of a difference here because it is plausible the difference is 0. Thank you. Okay? So we have a minute left for you to get those notes down. We'll pick up the Monday after break first with those projects. I'll give you that feedback, but first with the projects, right, Ian? And then we'll do the check your understandings with this. And then after that, we will start hypothesis testing. Tuesday after Thanksgiving break, you're going to have a DYU on confidence intervals with means.
Wait, so what day? When?
The Tuesday after Thanksgiving break, you're going to have a DYU on confidence intervals
So
with
after our
means.
projects,
Yes.
okay.
So, projects first thing before lunch on Monday. Then the check your understanding for the the difference in 2 means confidence interval. Start hypothesis testing, which means I guess I need to open up a progress check. Don't worry about it until maybe the end of Thanksgiving break, but there is a DYU on that Tuesday, so you look at that progress
Why
check.
don't you just give them the whole thing?
Wait, what?
That's the plan, huh?
You have a project?
Progress check by the end of Thanksgiving break, so that we can go over it Monday, DYU on Tuesday. Because we're probably going to finish up this whole unit next Friday, or close next Friday, because we have one more unit before the end of this course and then exams. Huh? What? Next I think I'm going to make it a project. Final project. Huh? Actually, the project grades are typically way higher than test grades.
Where are they? What are you looking for? I know they're over here somewhere.
What?
The grades.
Dude, the grades aren't there, the tests are there, but the grades are not there. No way.
You did well.
I got like a million.
You did really well. No way. Too bad to go, bye. You did make 100. Bye. You did pretty well.
That's okay. You can't be this the whole time.
I can, and I will.
Can I at least look at the document?
I'm not curious about what I got into. He said I already graded it.
I will show up to your door.
Okay.
And I'll
won't
come there.
be there,
I'll
okay.
come there.
I'm not telling you. We'll find out the
I
Monday
don't
after.
even want to know what grade I made. I just want to see what I did wrong. So what lengths I did wrong.
You were super close here. The reality is though, it's not that it's just plausible of it being 0.2. There it is plausible.
So
way type 2 error is, you never talk about the fact that because he doesn't believe that you're before, he's not migrating the program
The one time.
like he's missing out, right? Like the context is that.
Yeah, it's not bad.
Did I understand a question?
I know you.
Just a question.
Did I?
Wait, so I got all that to you?
Say yes or no. Fine. That's how you get it.
I'm so stupid.
Okay, so
Huh?
the group had
What?
bad. Something like yourself.
I think it was a high percentage. You made silly mistakes on multiple choice. You actually had, I think, the strongest or tied for the strongest grade on the response.
I'm gonna go and
You
get
made
my
a
little
couple of
seat.
mistakes. Like the one where I gave you the interval, you didn't get the right point estimate. I think you said that you couldn't know it, but it's just the middle of the interval, it's the average of the two intervals. Did you do that? Yeah.
No,
Algebra 2, go ahead and grab a seat wherever you want.
grab a seat.
Yep. What's up?
I'm not wanting to talk to you
Hold on a second.
May I go to the restroom?
Go quickly. Here you go. Thank you. Wherever you want. Just find a seat. Say again.
And then if you cookie. Wait, cookie for me.
They'll be alright. They'll survive. There's worse things. Do you have a question as well?
Yeah.
Okay.
Do you know if they like
Go and grab a seat wherever you want.
like practice ACT tests like in a new version?
They haven't released any yet. The only test they've released, they're releasing the October practice test, or the October test. But, well, I can send you
Last time it
some,
was me,
but they're not.
Carter, Junior.
What they did is they took the old test and they just like took out answer choice for the math. They retour math for the research.
Damn, who sit back here?
But those questions are not accurate.
I'm gonna let money move it.
Just do what you can with those though. That's all I have. The October test is the first one.
Specifically,
Test? And sure you got it.
Who's one?
That's all you got. And she'll send that to you. Then you have that.
Carter.
You took the October test.
My
But
turn.
you're not the smart one. I didn't even invite me. You can ask her for it, or at least get it from your friend. Because like it's still a blank version of it. Right? You got a bit. Like specifics. Matter of fact, I don't know that answer. I mean, like, what algebra? I mean, you and I can sit down and talk about algebra during first lesson.
My math score went down.
I mean,
It's the only thing.
but I can't specifically use algebra.
I'm gonna paint it. And I'm put some LED lights in it.
First log line, you get out of TA, let's take advantage of it.
Like,
But, you have a great thing too, great. Algebra 2, hey guys, I need y'all seated, our money, Bev, I assume that's you, yeah.
Like a little review right there.
Grab a seat, no. That's what we literally did yesterday.
No, I'm just saying like.
I'll give you this,
Did we like study for like 20 minutes?
I don't need
did you not study last night?
Yes, I just need to study one more time.
Where's a quick like recap?
We got a whole block.
They can't get recap.
No, I'm not giving you a recap, do other teachers give you a recap?
Yes.
Yes, they do.
That's not realistic.
They
That's not really what they
study for at
learn.
least 10 minutes for one test.
So that's why we've learned to not study before class. Like, I need you to understand, that's not healthy and accurate. Like, that's not how learning works or how testing should work. Okay, sure, you can have 5 minutes and I'm passing out the test.